Hello everyone. Today we're doing a mass balance example with crystallization. As you can see, the problem statement is that a saturated solution at 100 degrees Celsius is cooled down to 10 degrees Celsius, and they want to know what the percentage yield of sodium chloride crystals is. And you can use the solubility data given below to do the problem. So step one, when you do any of these problems, is always to draw the flow diagram so you can see what's going on. So what comes in is sodium chloride and water at 100 degrees Celsius. What comes out is again, and remember this first one is saturated. What comes out is a saturated sodium chloride solution again, only this time at 10 degrees Celsius. And at the bottom we have the sodium chloride crystals. So that's all the information we have for now. We don't yet know what the composition of this first stream is or what the composition of the other two streams is. For that, we need to use the solubility data. So we can start with the 100 degrees Celsius, because that's nice and easy. So what you are given is that at 100 degrees Celsius, the solubility is 38.99 grams sodium chloride per 100 milliliters H2O. Now this is not a useful unit yet if we just want to choose a basis of saturated solution coming in. So we can do a unit conversion to convert it to a mass percentage. So first we want to get rid of the milliliters water so that we can get to percentage sodium chloride. Now to do that, we first need to go to mass. And for that we use density. And a safe assumption that you can make is that the density of water is 1,000 kilograms per cubic meters. That's always a safe assumption. So if I have my density in kilograms per cubic meters, I need to first fix these milliliters by converting it to cubic meters. There are 1,000 milliliters in 1 liter. That cancels out the milliliters. And then there are 1,000 liters in 1 cubic meter. Now that I have cubic meters, I can use the density. So if I want to get rid of the cubic meters, I multiply by 1 over the density. So it's 1,000 kilograms in the denominator and 1 cubic meter in the numerator. And we can just simplify that a bit. So now we have grams sodium chloride per kilogram water. So we can just also convert the kilograms water to grams. And 1 kilogram is 1,000 grams. So if you simplify this, you will get 0.3899 grams sodium chloride per gram water. Now we are one step closer to getting a mass percent. So if you want to convert this to mass percent, you can choose a basis of 1 gram of water, which means that for every 1 gram of water, we have 0.3899 grams sodium chloride. So that is the fraction of sodium chloride over the total, which is then 1 plus 0.3899. And then we multiply it by 100 for percentage. And our percentage sodium chloride in the saturated solution at 100 degrees Celsius is 28.05%. And we can then add this to our flow diagram. Now we fully know what's happening in this first stream, which I will label A, and this B and C. Now we still need to find out what is happening in stream B over here, because we know it is a saturated solution, because sodium chloride crystals will continue to precipitate out as you cool down until it becomes a saturated solution again. So for that, we need this solubility data again, but we are at 10 degrees Celsius, which is between two of the given values. So we will need to interpolate between 0 and 20 degrees Celsius. So just a quick explanation of the interpolation. Can fill in the solubility data at 0 and 20. So those are the two values we know. And we are going to approximate this with a straight line. Now, we don't know what actually happens with these data points. It could go something like this. But we are going to approximate what actually happens at 10 degrees Celsius with the straight line, like that. So this is an unknown. And this I'm going to call x1 and x2, y1 and y2 for the interpolation formula, which, as you should know, is y3 minus y1 over x3 minus x1. So that slope is the same as the slope of between the two known points. So if we rewrite that, we get y3 is y1 plus x3 minus x1 over x2 minus x1 times y2 minus y1. So x3 is our unknown and y3, or x3 is our temperature that we want to be at, and y3 is our unknown solubility. So we can plug into the formula y1 and then you will find that the solubility for 10 degrees Celsius is 35.77 grams sodium chloride per 100 milliliters water. Now again, these units are not very helpful. We want to convert them to a mass percentage, and you will do it exactly as we did before, and you will find that the solubility at 10 degrees Celsius is 26.34%. So we can then go back to our diagram and fill that in as well. So now we know in terms of percentage what is happening in all three streams, because this is just 100% sodium chloride. Now we can choose a basis, and I am going to choose 100 grams of stream A, which is 100 grams of the saturated solution, so that I can do the problem. And because we know the percentage, I know that there is 28.05% sodium chloride, which is then 0.2805 times our basis of 100. So there are 28.05 grams sodium chloride in stream A. So we know what the rest is. It's water. So then that is the 100 minus 28.05. And we are left with 71.95 grams water. Then we also know from looking at our flow diagram that all the water here went into stream B. So I already know that in stream B, there is 71.95 grams of water. Which means the rest is then sodium chloride. I also know that in terms of percentage, we have 26.34% sodium chloride and the rest is water. So then we have 73.66% water in B. Which means this 71.95 grams is 73.66% of the total. So 73.66% of the total B is equal to 71.95. So I can solve for the total mass in stream B, and that is 97.68 grams solution. And again, I know that 26.34% of this total is sodium chloride. So to get the mass sodium chloride, I multiply the percentage by the total mass. And I have 25.73 grams sodium chloride. So now that I have the sodium chloride in stream B, I know that the difference between stream A and B is stream C, because everything that didn't go into stream B would have gone to stream C. So the sodium chloride in stream A is the sum of the sodium chloride in B and C. So for that, we know we had 28.05 minus 25.73, and we are left with 2.32 grams sodium chloride. So that is how many crystals actually precipitated out. So the percentage yield, you can check the definition of that in 8.6 on page 59 of your class notes. So the percentage yield is what we actually got out over what we could have got out. So if all the sodium chloride crystals precipitated out, we would have had 28.05 grams. But we only precipitated out 2.32 grams. So that is the fraction that precipitated out, and we multiply it by 100 to get percentage yield, and then we find that our yield is 8.27%.